Brilliant. Let's start. So we've covered quite a lot in terms of the atmosphere, its evolution to where it is today. Um, and what we're going to after half term is look at organic chemistry. And organic chemistry really links in well to the atmosphere because part of it is to do with fossil fuels and how that's affecting the composition of the atmosphere. And organic chemistry really has a lot to do with crude oil. And that's where we're going to start. It links in very well to next lesson. Okay, so I'm going to go through key words. And the reason being, there's quite a lot of year 11s who don't know what crude oil is. It's a thick black liquid like this. And yes, they know it's a thick black liquid. It is useless to us. It means nothing in terms of what we can do with it. Until you realise that what it actually is a mixture of lots of different things. So crude oil is a thick black liquid. You find it underground and it contains many different substances. The kind of substances I'm talking about is it contains petrol, diesel, kerosene, the fuel that ships use, every single kind of fuel generally that we use you can get out of crude oil, or you get out of crude oil, not that you can get. And I'm not talking about wood, that's a fuel. I'm talking about fossil fuels. Generally speaking, the majority of commonly used fossil fuels come from oil. The only ones that don't is coal. So coal is a solid, oil is a liquid. The actual definition of a mixture in chemistry is two or more substances that are not chemically combined. They are just mixed together. Now, in terms of crude oil, different parts of crude oil. Now, petrol has a different boiling point to diesel, but we're going to look at that in detail. And we call that little part of crude oil a fraction. So that fraction of crude oil has a specific melting point, boiling point. Evaporation, turning a liquid into a gas by heating it. Condensation, turning a gas back into a liquid by cooling it. Boiling point, the specific temperature at which a liquid turns into a gas. So water has a boiling point of exactly, this is pure water, of 100 degrees Celsius. So what is crude oil? It's a fossil fuel and it's made from dead creatures that have been slowly decaying over millions of years. It's a mixture of different sized molecules called hydrocarbons. They're called hydrocarbons because they're made of hydrogen and carbon. Crude oil is heated until it turns into a gas. It's just over 350 degrees. And it all turns into a gas. This gas enters a fractionating column or a fractional distillation column. The column is hot at the bottom, you can see it on the right. It's hot in the bottom down here and rather cool at the top. Okay. How it separates is that large molecules, because hydrocarbons, there is a mixture of hydrocarbons. There are small hydrocarbons and big hydrocarbons. The big hydrocarbons stay at the bottom. The little ones fly out the top. Now, the ones in between are right there. But I'm just going to focus on the big and the little ones first. The big ones are so big, their boiling point is so high that we use them to make roads. And that's what we call bitumen. The light gases we use as LPG, liquid petroleum gas. Use it in caravans, in cabins, anything off-grid. And you can use it for cooking. Now, as I said here, the large molecules have high boiling points and turn into liquids at the bottom. Small molecules have low boiling points and rise to the top before turning back into liquid. Common uses of hydrocarbon: petrol in cars, kerosene in jets, diesels in trucks, and bitumen on roads. All right. So this is really rather important because, as I said, I am shocked at how many Year 11s don't know this. this is a big marking criteria, and actually it's quite interesting as well, because it tells you about the issues that the atmosphere has, and we're going to, and because when we burn them, we produce carbon dioxide and water, and both of those are greenhouse gases. All right, you've got a set of questions as per usual. Let's rock and roll.